Good morning students, welcome to the section of data structures. In our previous lecture we have seen how we are going to represent the elements in your two-dimensional array and how it will be stored in your memory and how we are going to calculate the address of a particular element of a particular indices of your matrices that we have seen in our previous lecture. And I have given some example and I told you people to do this. I hope all of you have done, but I am discussing this for those who didn't understand the logic. Okay, and see, in case of a two-dimensional array, we will be having indices in a row and column format. We will be having rows like this. See, this is a matrix where it will be consisting of 3 rows and 4 columns. 1, 2, 3 rows and 1, 2, 3, 4 columns. These are the indices 0, 1, 2 and 0, 1, 2, 3 are column indices. Okay. Now this can be stored in your row representation, row major representation, as well as column major representation. Column major representation. See, in both cases how we are going to store the elements. In this case, particular row major case, we will be storing the first row first and then second row and then third row. See, in a first row we are containing 25, 1, 20, 15 and 11, 0, 2, 21 and then 5, 7, 9, 10. Like this, one after the other, we will be storing in your row major representation. So this is how we will be storing it in the form of row major representation. See, this is the first row and this is the second row and this is the third row. And given information is that the base address is 500. For every representation, the base address will be the same one, 5000 I think so. Okay, and they want us to find the address of this particular element, that is A of 2 and 2. We are going to see, but in case of column major representation, we are going to store the elements like this. First column will be stored, second column will be stored, third column and then fourth column. See, elements will be stored like this: 25, 11, 5. This is the first column. 1, 0, 7. This is the second column, and third column is 20, 2 and 9. And then we are having one more column like 15, 21 and 10. You can observe the difference between row major representation and column major representation. Okay, so this is the first column and this is your second column and this is your third column and this is your fourth column. Like this we are going to store the elements in your column major representation. Okay, see, now I will try to find the address in column major representation as well as row major representation. Okay, we are having the formula, just I will be implementing with these particular values. Okay, and see, in case of first case, that is row major representation, we are having a formula like A of ij, that is what they want to find us. I will be giving within this A ij, and I will be having the base address plus w, that is the size of element, I into number of columns, plus j, and for column major representation I will be having the formula like this: A of ij is equals to base address plus size into I plus j into number of rows. See here, the number of rows, that is m is equals to 3, the number of columns, that is n is equals to 4, and size of the element, that is w is equals to 2. Why? Because we are storing the integer values. These are the basic information that we need to find the address. The base address given is 5000. Okay, now for row major representation, they want to find the address for A of 2, 2, and I will be placing within this. Okay, base address is 5000 plus size of the element is 2 and I is 2 and n is number of columns, that is 4 columns. plus and j. J is what? J is also 2. See here, 5,000 plus 2 into 4 will become 8. 8 plus 2 will become 10. And 10 into 2 will become 20. 5,000 plus 20. And the final address will be 5,020. Now let us check whether it is correct or not. See, in this particular case, this will become 0, 0. This will become 0, 1. And this will become 0, 2. This will become 0, 3. Like that only we will be having the remaining rows. 1, 0, 1, 1, 1, 2. And then 1, 3, 2, 0, 2, 1. And 2, 2. And then 2, 3. See here, every element will be holding 2 bytes of memory. Then it will become 5002. This will become 5004. This will become 4006. This will become 5008. This will become 5010. This will become 5012, 5014, 5016, 18, and then 20. This will become 5022. See, our address is correct. At 5020, I am finding the element of A of 22. A of 22 is what? 9. At this particular address, I am finding my element. See, this is proved. The second one is column major representation. In the column major representation, we are having the base address as 5000 plus data type size is 2 and given I is 2 plus j is also 2 and number of rows are 3. Then 5000 plus 2 into 3 will become 6. 6 plus 2 will become 8. And 5000 plus 16, that is 5016. Now let us try to observe that in the result. Okay, 5000, 5002. See, as it is holding 2 bytes of memory, we are taking this. This is 5004, this is 5006, 8, 10, 12, 14, 16. See this. At 5016, I am finding 9. 9 is nothing but what? Your A of 2, 2. Okay, like that we will be finding the address of each and every element in your 2-dimensional array. I hope it is clear to you people. If you are not getting anything, just try to ask in your group or else comment in your video so that I can clarify you people and we will go for the next session. Okay, I hope it is clear to you people. Okay, I will be sending you one more example. Do that and send me the answers. That's it for now. Thank you.